This problem gives us a volume, a temperature, and a bunch of grams of different gases. From those grams, I can find moles. So before even looking at the question, that's just work I know I can do. Why finding moles is going to be helpful? If I'm looking for pressure, but I have volume and temperature, PV equals nRT has pressure, volume, temperature in it. It also has moles. So for neon, grams equals moles times molecular weight. My moles of neon, 6 divided by 20. For nitrogen, remember that nitrogen is a diatomic, so really it's N2. 14 grams equals moles times nitrogen, 14 times 2. My moles of N2 is 0.5. And for argon, 15 grams equals moles times the molecular weight of argon, which is 40. Dividing that, we get 0.375 moles for argon. So now with moles, volume, and temperature, I can find pressure. Part A is asking me to find the total pressure. So if I want the total pressure in PV equals nRT, I need to use the total moles, meaning adding all of those up. 0.3 plus 0.5 plus 3.75 is 1.175 moles total. To find my total pressure, I will use the volume they give me, but in liters. My total moles, R is always 0.0821, and temperature I need to add 273 to put it in Kelvin. Multiply all of these together, divide by the 2.5, and I end up with a total pressure of 11.6. In this formula, pressure is always an ATM. There are two different ways I can approach part B. Whichever way works for you is fine with us. If you want to approach it the same way, you can, instead of using total pressure though, since we're looking for the pressure of just neon, I would use the moles of just neon. Pressure of just neon, same volume, but moles of just neon, R and T are all the same. And we would solve that for partial pressure of neon. Or you can know that the total pressure times a fraction is only a fraction of, you can know that neon's partial pressure is only a fraction of the total pressure. So if you multiply the total pressure by the fraction of the total moles that are because of neon, that is finding you, well, what percentage of the total pressure is neon's partial pressure. Either way, solving this for partial pressure of neon or doing this math out, you will end up with an answer of 3.7 ATM. That's it.